Hello, Mr. Chan here for Algebra 2. Topic 2 review. Grab your review packet, page 124 onward. These were the worksheets I gave you at the beginning of the year. And let's get started. We have some vocabulary to begin with. And let's go ahead and read along as I read along out loud. We have a vocabulary list: completing the square, complex number, discriminant, imaginary number, parabola, quadratic function, standard form, vertex form, and zero product property. This was a long chapter, so I hope you guys have enough stamina. We're going to be going a long ways here. Number 2, according to the blank, a product is zero if and only one or more of its factors is zero. This is applying something called the zero product property. Write that down. The zero product property. Great. Number 2, the blank of a quadratic function is y equals a parentheses x minus h close squared plus k. This is the vertex form. A's, h's, and k's. A carryover from Algebra 1. Number 4, the blank of a quadratic function is the value of the radicand, b squared minus 4ac. That thing right there has a name. It's called the discriminant. b squared minus 4ac is called the discriminant. Great. Number 5, a number with both real and imaginary parts is called a imaginary or a complex number, actually. My bad. Both the real and the imaginary parts is a complex number. Great. Number 6, the blank of a quadratic function is y equals ax squared plus bx plus c. This is just standard form of a quadratic. And number 7, blank is a method used to rewrite an equation as a perfect square trinomial equal to a constant. PST, perfect square trinomial. Psst. That method, of course, is completing the square. All right. That takes care of the vocabulary. Let's move to section 2.1. Vertex form of a quadratic function. There it is. Let's write it a little bigger so we can see it better. Y equals a times x minus h squared plus k. All right. Just a quick reminder, this is from Algebra 1. A, of course, is the vertical reflection, stretch, and compression. We also know compression as shrink. And of course, HK is referring to left, right, up and down movement. We're shifting. Okay. Let's take a look at number 8 and describe the transformation. This should be all reviewed from Algebra 1. If you have any questions, please ask me. I don't mind helping out. Who is the parent graph? Aha, x squared. That is my parent graph. We all know what that looks like. It's a parabola, U-shaped graph that opens up with 5 major dots, 0, 0, 1, 1, and 2, 4. This should be automatic in your brain. I'm going to also graph it here on the left side. It's a symmetric graph. Okay. It does have an axis of symmetry, as you know, the AOS. Normally it's x equals h. My vertex is at hk. All those parts we should know by now. Great. So looking at number 8 here, what's going on? That's the question. So we have a function, g of x, and sorry about the crampness. There's not a lot of space over there on the left there. So I'm giving myself some space on the right. You might have to use some scratch paper for this review. There's not a lot of room here. That 2 is on the inside, and it's a h value. You got to think backwards of +2. This is -2. -2 means I'm going to go left. That's shift left. The other value, -4, is on the outside. That one is up-down movement, so this is called shift down. Now we know shift as, they're all called translations, just a reminder of that. Those are your translations, okay? That takes care of number 8. Not too bad. Let's go ahead and do number 9. This time we have a coefficient in front of the parentheses. That's definitely your a value, along with your hk's. Your a value in this case is -2. Not only is there going to be a vertical reflection because of the negative sign, the 2 is a 200% multiplier. That's a stretch. Along with the hk values. H in this case is backwards of -1, +1. This is going to shift right. And the +5, of course, is positive. We're going to go up with that. Because your k value is 5. I realize that these two problems are asking for a graph. Okay, let's graph those. Number 8, shift left 2 and 4 down. I'm moving my parent graph. The new vertex is at -2, -4, right there. And it's opening up. Those 5 dots. So there's your child graph right there. Yay. Relative to the parent graph. Right there. Okay, that was the parent graph. Forgot to do that for number 8. Sorry about that. Now, we can always check it with our technology, either a graphing calculator or Desmos. Let's switch over. Let's see what number 8 looks like on Desmos. Forgot to show you earlier. Bam. We have our parent graph in red, as you can see. I can zoom in. You can see that right there. And I'm going to go ahead and click on number 8's value. Oh, there it is. -2, -4 is my vertex. There it is. -2, -4. Very good. How about number 9? Let's see what happens there. Oh, it's upside down. And its vertex is at +1, 5. There it is. Is that what we have here? Let's take a look at. There it is, +1, 5. And it's stretched vertically. So let's reflect that in our graph. 1, 5 is the new vertex. And it's stretched by a factor of 2 after it's reflected. Now, I kind of jumped the gun here. Let's take this slow. I apologize. Put your parent graph in, stretch it, reflect it, and then move it. Those are the proper movements for that. So let me zoom in a little bit more so you can see it better. The 5 points are 0, 0, 1, 1, 2, 4. I need to stretch it, doubling it first. So 0, 0 goes nowhere. 1, 1 goes to 1, 2, and mirrored over here on the left. 2, 4 goes to 2, 8, way up here somewhere. Running out of room here. 4, 5, 6, 7, 8. So the orange dot should be right here. And mirrored over on the other sides too. Those 5 orange dots get to be flipped upside down. So I'll flip those two. 0, 0 goes nowhere, and the other one gets flipped upside down as well. To 2, -8. Yeah? Okay. All right, those 5 orange dots will now be moved 1 right, 5 up. 1 right, 5 up. Right there. 1 right, 5 up right there. And right there. Woo! It's kind of hard to see, but I think I got it. There it is. It's stretched, it's reflected, and it's been stretched by 2. It's upside down. Yeah. All right, that takes care of number 9. That's what it looks like, right, from what we had a few moments ago. Any questions? Let's take a look at number 10. Identify the vertex, axis of symmetry, maximum and minimum, domain and range of each function. That's a lot going on there. All right, wish us luck, number 10. It's kind of cramped here. Let's just do the best we can. All right, there's number 10. It's in vertex form. Identify A, H, and K. A, of course, is -1. H is -3. K is +2. We have formulas for all that stuff. Just a reminder, vertex is HK. Axis of symmetry is X equals H. It's a vertical line. You have a maximum minimum depending on which way it's opening. Maximum if it's opening down. Minimum if it's opening up. Domain and range, that's easy. Okay, let's do this. Crank this out. The vertex is at -3, 2. Ding, 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 ding. Axis of symmetry is next. AOS. X equals -3. Nice. So far we have some information here. There we go. And it's opening down because of the negative sign. Yeah. That means we have a maximum. It is referring to the y value. It's the y value, which is k. The k value here is 2. So you just indicate it that way. Okay. Domain, that's pretty easy. It's a parabola that opens left and right forever. So it's all real numbers. If I were to use interval notation, we would have this, of course. And finally, the range. Which way it's going, up and down? It's going down from 2, isn't it? From 2. From 2, including it, it's going downward. And if I were to use interval notation, it would go all the way down to -infinity forever from +2, including it, bracket. There is number 10, folks. Domain range. Okay. Let's cram in number 11 here. Hope I have room. It's getting crowded here. Same process. For this parabola in vertex form, let's identify all this stuff. A is +3. H, of course, is +4. It's backwards there. K is -3. Great. Alrighty, vertex. 4, -3. Reading it off from the data I just got a second ago. Nice. Axis of symmetry is next. We have x equals the h value, 4. Nice. This parabola is opening up, which means we have a minimum. That is our situation. The minimum is still the y value. Y equals -3. Nice. Domain and range is very similar. All real numbers for the domain. And there's my interval notation right there. And the range is next. Range this time is going upwards from the lowest point. The lowest point is -3. And it's greater than or equal to that. Let's use some interval notation for that. The lowest point is -3, so it's bracket -3 to infinity forever. Up. Yay. Any questions? All right. Wanted to show you, I think I did do this on Desmos. Let's see what they look like. Just curious. These are number 10 and 11. 10 and 11. Okay, very good. There's number 10. Oh, nice. It is upside down. And here's number 11. Bam. Definitely stretched triple there. You can see that. Very good. All right. Let's move on back to the notes. Any questions so far? Okay. I hope oh yeah, I do have some room here. 12 and 13 and 14 are last. Let's jump to number 12. Write an equation of each quadratic function in vertex form. Now, remember, we wanted to put it into y equals a times x minus h squared plus k. Our goal is to come up with what a, h, and k are. And that can be found by looking at the information given to me. We are given a vertex. That's hk, everybody, for both 12 and 13. We're given a random point. That helps determine how wide or how skinny or whether it's reflecting this particular parabola. So that's your random xy value. All you have to do is plug it into that formula and figure out what your a value, your stretch, shrink, or reflect constant there. So let's do that for number 12 first. Plug it in. I'm going to plug in 0, 4 for x and y, right there. And I'm going to plug in 2, 1 for hk, right there. Clean up the rest. And just watch out for your signs and everything. 0 minus 2 is first, is -2. -2 squared is +4. Okay, great. Go ahead and subtract 1 to both sides. Oh no, we have a fraction, no! Divide 3 by 4. Sorry about that, looks kind of funny. A equals 3/4. Which means I'm done, yay. Final answer, reset x and y. Y equals 3/4, the answer we just got, times x minus 2 squared plus 1. This is my equation for that particular problem involving 2, 1 and 0, 4. Let's take a look. Did I graph it over there? I think I did. Turn those off. 2, 1. Oh, there it is. 2, 1 is my low point right there. 2, 1. And 0, 4 was the random xy value right there. And you can see it does match it nicely. Very good. Let's go ahead and do number 13. Same process. y equals a times x minus h squared plus k. This time we have a couple of different points. 3, -1 goes in for xy. 3, -1, great. Then we have a vertex at 1, 5. Plug that in, okay. Clean up 3 minus 1 is 2. 2 squared is 4 inside the parentheses. Subtract 5 to both sides now. Solve for a. Whoops. -1 minus 5, of course, -6. Divide through by 4 to both sides. And a equals, reducing that improper fraction, -3/2. Yay, dun dun dun. Final answer, y equals -3/2 parentheses x minus h is 1 squared plus 5. Good job. Woohoo! Wow. All right. Any questions about number 13? All right. This is a long review. Go take a break, pause the video, whatever. Number 14. The graph of a function f of x equals x squared will be translated 4 down and 2 units right. When I see 4 down, I'm thinking of k is -4, and 2 to the right is h, +2, which means my answer, with no stretch, shrink, or reflections to worry about, y equals to x minus h squared plus -4, or just write -4. Yay, there it is. That's number 14. Not too bad. And I think I did that. Decimals. Let's take a look here. Oh, no, I skipped that. Oh well, no big deal. Whew, that takes care of the first section, ladies and gentlemen. Crazy. Let's move on to the next section. Again, if you need to take a break, please do so. Let's move on to the standard form of a quadratic function. Again, this is review from Algebra 1. Y equals ax squared plus bx plus c. Some things that will help us out are this formula right here that I've talked about and proved. H, or x, equals to -b over 2a will give you the axis of symmetry. It's also the x coordinate of the vertex, just to remind you that, okay? One other thing is you can find the y-intercept by setting x equal to 0, which literally means the y-intercept is right there, c. Only because the x's go away right here and right there, leaving with the c. Just want to point that out. Let's try some problems. Number 16. Find the vertex and y-intercept of the quadratic function and use them to graph the function. Wow, okay, let's do it. Give myself a little space. You're going to need some space yourself. Here's number 16. Y equals to x squared minus 6x plus 15. And if you need to compare, there's your a right there. A is 1. B is, of course, -6. And C, of course, is 15. In fact, 15 is your y-intercept. That's where the parabola crosses the y-axis. Okay? I do need to find the vertex of this particular quadratic. So let's find it. Here we go. So use the formula. X or h, doesn't matter, equals -b over 2a. Plug it in. Plug the values you know. B, of course, is -6. A, of course, is 1. Clean that up. -6 is +6/2. That equals 3. That's for the x value. We need the y value now. To find the y value, you plug it into the original problem. We just got 3, didn't we? That's your x value. That gets to be put into here as well as over here. Okay? And then you clean it up. 3 squared is 9, minus 6 times 3 is 18, plus 15. That equals -9 plus 15 is +6. Ding, 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 ding. Done. Nice. So that means the vertex is at 3, 6. And you're done. Along with the y-intercept. 3, 6, and 15, right? I do want to show you that from decimals. Did I put it in? I did, way down here. Okay, fine, boom. X squared minus 6x plus 15. My vertex is at 3, 6. My y-intercept is 15. There it is. Very good. Let's go back. Ready for number 17? Woo, a lot of problems. It's gonna be a long lecture. This will probably be the marathon because there's 7 sections. That's crazy. All right, here we go. Right off the bat, my y-intercept is 9. Make sure I identify A, B, and C. Plug it in to that formula, -b/2a, to help you find half of your vertex. Plug the numbers in. Clean it up. And 15/8, it's done, yeah? That's gonna be ugly, ugh, ooh, don't wanna do that. Oh, I forgot to mention, number 16, the graph, totally forgot about that, sorry folks, ha ha ha, for number 16, looked like this. All right. For number 17, I believe we can just rely on the graphing calculator because right now I do not want to put that 15/8 into my equation. It's going to get an ugly answer. So let's switch over to the graphing calculator. Sometimes you have to do that. Excuse me. And see what happens if I turn on this one. There it is. Oh, wow. I was right. 1.875 was literally that fraction I showed you a moment ago, right? And when you plugged it into the equation, you'll get -5.063, okay? So let's graph it for ourselves. And remember that, okay? We're going to transfer that, 1.875 and -5.063. That's the vertex. All right, here we go. So using a graphing calculator, because that's just very difficult to do. This is what we get. Sometimes you forget what things look like. Oh, there it is. Goes through the x-axis twice. Okay, gotcha. Gotcha. Sorry, kind of jumped there a little bit. But the key is the vertex. The vertex is at, dun, 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 dun. 15/8 is 1.875. And the y value is negative 5.063, and that's probably rounded. All right. Sometimes they give us problems that are not nice to do by hand, so we utilize the graphing calculator for that one. All right, or decimals in this case. Number 18 and 19. Write an equation in standard form for the product that passes through the given points. This is going to require statistics. We need to use quadratic regression. Whether you're using Desmos or the graphing calculator, let me remind you how to do that with Desmos. I have the app ready to go. Or with the graphing calculator, you want to use stat. You want to graph it. And you want to calculate x squared. On other calculators, it's called quad reg. So be patient. I'm going to go ahead and take number 18 and 19 and use Desmos. Right now, I have something ready to go here. Here we go. I'm going to put in all the x values. So the first value is 1, 5. Great. Second one is 3, 7. This is very handy. Found this on the internet when I typed in Desmos quad regression, and somebody already made it. I'm just utilizing their little app that is built from Desmos. So see what's going on here? It is building a parabola based off of those 3 points. It's really neat. And the equation down here is, and you can see the answers right here, 1x squared minus 3x plus 7. And that's the graph. Really cool. Let's copy that back over to the other side on our notes. There we go. So my answer for number 18, using that is 1x squared minus 3x plus 7. Using technology. That's the only way you can do this. There's really no other way to do that. Number 19 is coming up. And I'm going to give you the answer ahead of time for those crazy numbers there on the left. The answer should be 3x squared. We're going to double check the math here. Minus 19x with our technology plus 14. Okay, fingers crossed. Here we go. Back to Desmos. They are negative 264, negative 16, and 728. I'm going to have to zoom out a little bit here. Whoa, there it is. And I have the answer, yay, 3x squared, negative 19x, and 14. There it is, folks. That's great. Okay. So we verified it. Any questions about section 2-2? We are going to finish with this section, moving on to the next section. If you need to take a break, please do so right now. All right, moving on. Third section. The factored form of a quadratic function. Now, we're assuming you know how to factor quadratics, ax squared plus bx plus c. How you get there is the challenge. Did you learn by guessing and checking? Did you use the AC method? The box method? The diamond method? The hybrid method? Wow, so many possibilities. All right. So it's up to you to utilize what you know from Algebra 1. Let's get going. 22. We're asked to solve each quadratic. We will be invoking the zero product property here in a moment. X squared minus 6x minus 27 equals 0. I'm going to guess and check this particular problem because my a value is 1. It's so easy when you have a equals 1. What I want to do is I want to see what numbers when multiplied together will give me negative 27, when added together will give me negative 6. So in my head, I am thinking of all the possibilities. This is for guessing and checking of negative 27. I'll start listing them. Oh, look how close that was. Negative 3 and 9 will give me positive 6, which means positive 3 and negative 9 work. Ding, 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 ding. There it is. Plus 3 minus 9, right? The inner and the outers must add up to the middle term, negative 6. That works. That's guessing and checking. That works really well when a is 1. All right, I have a factor, x plus 3, and another factor, x minus 9. They multiply together, give me 0. So using the zero product property, that allows me to split it up. That's allowed. Okay, split them up and solve. X plus 3 equals 0, x minus 9 equals 0. Subtract 3 here, add 9 over here. Okay. Two answers, x equals negative 3 or x equals positive 9. Yay! That was easy. Let's try number 23. X squared equals 7x minus 10. It's not in standard form. They're being a pain. Got to move the 7x over and the negative 10 over. Let's do the opposite. So when you do that, you'll get x squared minus 7x plus 10 equals 0. Ooh, a is 1, which makes my life easier. I'm going to guess and check here. What factors of positive 10 when added together will give me negative 7? I'm thinking 2 and 5? Yes. But they both have to be negative, though, in order for that to work out. Negative 2 and negative 5. Yay. Using the zero product property, split them up and solve. X minus 2 equals 0, or x minus 5 equals 0. Add 2, add 5, and we have two answers. X equals 2, or x equals 5. How are we doing? Sound good? Okay, any questions? Let's take a look at number 24. Aha, more factoring. 4x squared plus 4x equals 3. I got to move that 3 to the other side, don't I? Fine. Got to put it in standard form. 4x squared plus 4x minus 3 equals 0. I'm a little worried about this particular problem. Guessing and checking is going to be difficult. I'm going to go ahead and use the box method and see what would happen. Here we go. Wish me luck. All right, this is the hybrid box method. First term with first box. Last term, last box. Middle term, lower left-hand corner. Multiply the downhill product. Find all the possibilities that when added together will give me the try to get 4x. Let's see, 6 and 2. Oh, yay, 6 and 2 will work. One of them has to be negative, so it's -2. There we go. Put those two terms in here. Great. Last step, greatest common factor for each row and column. First row is take out a 2x. Second row, you can take out a -1. First column, take out a 2x. Last column, take out a 3. There it is, ladies and gentlemen, using the AC box hybrid method. This gives me 2x minus 1 times 2x plus 3 equals 0. Split them up and solve. 2x minus 1 equals 0. Add 1, divide by 2 to both sides. Sorry about the crampness there, everybody. X equals 2, 1/2. You all see that? Over here, 2x plus 3 equals 0. X equals 2, subtract 3, and divide by 2. There they are. 1/2 and -3/2 are your two answers for number 24. Nice. 25. 5x squared minus 19x equals -12. Add the 12 to both sides. Oh boy. This one's kind of scary. In fact, I might have to do the hybrid box method again. Well, this one, I can't guess this one. That's way too difficult, beyond my brain. Oh boy, kind of scared. It's in standard form now, put in the box. First term, first box. Last term, last box. Middle term, bottom left-hand corner. Oh boy, should have tried this ahead of time. 5 times 12 is 60x squared. So I need two factors, have to be both negative in order for it to add together to be -19. And when multiplied together, it will be +60. All right, let's do all the possibilities here. 62, 33, 20, 4, 15. Oh, there it is, 415 work, ladies and gentlemen. Whew, that was not easy. Hurt the brain a little bit. Glad I did that though. Greatest common factor for each row and column. First row, take out a x. Second row, you can take out a 3, but it has to be negative because the leading term is -15. First column, take out a 5x. Last column, take out a -4. A little cramped here, sorry about that. Set it equal to 0, x minus 3, and 5x minus 4 equals 0. Split them up and solve individually using the zero product property. Wow, it worked. Wow. Okay, I'm just solving. Here we go. X equals 3, and over here, x equals 4/5. That's correct. Those are your two answers. Woo! Crazy. All right, we got to move on to number 26. Take a break soon here in a minute. Hey, identify the intervals on which each function is positive. Y equals x squared minus x minus 30. Positive? What does that mean? What they want you to do is to graph this and see where it's poking above the x-axis. So number 26 here, find myself a little room here, a little cramped, sorry. Y is equal to x squared minus x minus 30. It's definitely a parabola that opens up. Alrighty. And positive means, oh, it has to be greater than or equal to 0. That's what it means. So that's what we're looking at, folks. This is the positive part. when you read it backwards. Okay, positive reading backwards. All right, I can break that up though and find out where it crosses the x-axis. That's what a 0 means. When you're solving, you're literally finding out where your parabola crosses the x-axis. All these answers we've been getting so far, number 22, 23, 24, 25, those are all x-intercepts. That's what they mean. Please understand. Zeros, x-intercepts, solutions, they all mean the same thing. This is where it crosses the x-axis. Okay, these are all your answers that we've been getting. Back to number 26. All right, what times what equals negative 30? When added together will give me negative 1. 5 and 6, that sounds right. One of them has to be negative. I'm going to put it on the negative 6 because it has to be bigger to give me a negative 1x in front of there. Split them up and solve. So what this means is that when you solve this, x plus 5 equals 0 and x minus 6 equals 0, x equals negative 5. When you move it to the other side, x equals positive 6. What that means is that that's where it crosses the x-axis. Negative 5 and positive 6. This parabola opens up because I know your a value is positive. So there's some kind of parabola that looks like this. Question, where is it positive? Well, this portion is positive and that portion right there is positive. I just have to put it in with inequalities to explain where is it positive. Okay, so that's going to be negative 5 or less, but I don't want to include negative 5 because negative 5 is exactly 0. That's neither positive or negative. Or going the other way from 6. So there's your answer for it being positive. You can use interval notation for practice. Let's do that. Negative infinity, negative 5, union with 6 onward to infinity. There's the other possibility too, okay? Throw that in as well. All right. Number 27 is the same exact thing, different problem. Let's do it. Let's tackle that. Number 27. We have y is equal to x squared plus 11x plus 28. Again, they're asking for where this parabola is positive, meaning sticking above the x-axis, yeah? So in this case, we want 0 is greater than this thing. Now we can factor, yay. What times what equals positive 28 when added together will give me 11? Oh, this is a lot easier, yay. Using guess and check first. So you go through the list in your head, 1 times 28, 2 times 14, 4 times, 4 times 7. Both positive. Which means when you set this equal to, well, you know what I'm saying. This is a generic holder there, that's 0 right there. X equals negative 4, or x equals negative 7. Think about what this looks like. Negative 4, negative 7, it opens up because your a value is positive, opens up. And my answer is kind of the same thing as the last one, right here and right there. It's basically the same thing. Oh boy, wish it was a little different. Hopefully, I was hoping it would be upside down. Then I would have an intersection, not a union of two answers. All right? X is less than negative 7, or x is greater than negative 4 will be your first answer. And using interval notation, it looks like this. And that's it. All right. Ooh, time for a break? Okay. Let's move on to 2-4 if you're ready. Oh, that's a lot of work. This is going to be a very long lecture, isn't it? Oh, aha, complex numbers. A lot of vocabulary here. We introduced the imaginary unit. That's part of the complex number a plus bi. A plus bi has the real part as well as the imaginary part. We defined I as being the square root of -1. Now, the idea of imaginary or real, they're just words. They don't mean anything in math. They should have named it something else, like this is another system or something, okay? Imaginary doesn't mean it's fake, okay? So the imaginary part of the complex number is the bi part, yeah? So just throw that in. We have the real part, a, and the imaginary part. Again, this is just, it's a binomial. Just treat it like a variable, I. Now, don't forget the other powers of I, though. If I is the square root of -1, then that means I squared equals -1. Remember that's pretty handy. I to the third, if we were to crank it up, is -I. And then I to the fourth is equal to -1 times -1 is +1. Okay? So those are your powers that are important in this section. All right. So they have an example of a product of a 3.5i times 4 minus 6i. You can follow that. I'm going to go ahead and start playing around with the right. Starting with number 30. Here we go. Looks like I'm going to be multiplying a binomial times a binomial. 5 minus 3i times 2 plus I. And this reminds me of FOIL. Here we go. 5 times 2 is first. It's first term. Outer terms, plus 5 times I. Nice. Inner terms, minus 3i times 2. And of course, last terms, minus 3i times I. Okay, clean that up a little bit. 5 times 2, of course, is 10, plus 5i, minus 3i times 2 is 6i. And watch out here. -3i times I is minus 3i squared. And from earlier, I squared was -1. That's something that we'll need for this section big time. I squared is -1. Let's clean it up a little more. These can be combined together. -3 times -1 is +3. Right there. Okay. -3 times -1 is +3. All right, let's combine the reals together. We have, of course, 10 and 3. That gives me 13. And then 5i minus 6i is minus 1i, or just minus I. Yay, there's number 3. Any questions? 31 is next. Let's crank that out. It's another binomial. Same process, probably similar results. Now let's spoil that. Here we go. Okay, just the first terms, outer terms are next. Inner terms are the third. And last terms are last. Clean that up. Watch out for your double negatives right there, and clean that up carefully. Oh, here we go. Minus 6i squared, which is -1, yeah? I squared is -1. And -6 times -1 is +6, plus the -6 over here. Those cancel. Nice. Those go away. This gives me a final answer, and it's only an imaginary part. 9i plus 4i, treat like a variable, is 13i. Yay. Ooh, that takes care of multiplication. You guys ready for division? Uh-oh. Before we do that, we need to remind ourselves, in algebra, we do not like not only radicals in the denominator as an answer, we also do not like complex numbers. So we need to invoke something called complex conjugates right here. They help us cancel any imaginary units in the denominator. So the complex conjugate of this, a plus bi, is a minus bi. Those are complex conjugates right there, okay? Keep that in mind. We'll need to invoke that here in a moment when we divide, starting with number 32. Good luck, everybody. All right, so the problem is not the number itself, but having the imaginary number in the denominator. There's a technique called rationalizing the denominator. We need to rationalize the denominator. Because the denominator is a binomial, I need to multiply the top and bottom by its complex conjugate. Right now, the denominator is 3 plus I. The complex conjugate of 3 plus I is, dun, 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 3 minus I. If I do it to the denominator, I got to do it to the numerator as well. Because technically, I'm not really changing the problem. This is technically 1. That's just 1. I'm not changing the problem. It's like taking a fraction, like 1/2, and multiplying top and bottom by, say, 2. And when you do that, you'll get 2/4. Well, 2/4 is the same as 1/2. You're not changing the actual value. You're just changing how it looks. So by multiplying the top and bottom by the complex conjugate, 3 minus I, I'm not changing the value. I'm just changing how it looks. And we do not like imaginary numbers because it makes algebra very, very difficult. All right, all we have to do now is multiply those things together. Here we go. All right. I like to do the denominator first. Let's do first terms. 3 times 3. 3 times negative I times 3. Interesting. Okay, just changing the color. Forgive me there. So you can kind of see the progression here. And finally, I times negative I. Notice something interesting. When you multiply a binomial with its conjugate, whether it's radical, whether it's a complex number, the inner and the outer terms disappear. It's no longer foiling, it's FL, FL. And at the end, I squared becomes -1 right there. So that's something to keep in mind too. So on the bottom now, we have 9 minus -1. That's literally 9 plus 1. 9 plus 1 is 10. Okay, very cool. In the numerator, let's go and FOIL that. 5 times 3 and 5 times negative I. All right, that'll give me 15 minus 5i. Now the answer I have, 15 minus 5 over 10 can be reduced when you split it up like this. I know, crazy, huh? 15 over 10 reduces to 3/2 minus I over 2, or simply 1/2 I, which is the proper way of writing it. We have the real part, 3/2, and the imaginary part, 1/2, -1/2. All right. Whew, I think we're ready for number 33. Here we go. Similar problem. We still need to rationalize the denominator. Let's do it. I don't care about the denominator. The denominator is 1 plus 2i. The complex conjugate of 1 plus 2i is 1 minus 2i. And the whole point of doing that is to get rid of the 2 of the products when we FOIL. Here we go. All right. 1 times 1. 1 times -2i. I don't even need to write that, do I? Because when I do 2i times 1, those will eventually cancel each other out. And then finally, the back, you just have to be careful. Please be careful. Positive 2 times negative 2 is minus 4i squared. As you recall, I squared is negative 1. And in the denominator, I now have 1 minus 4 times negative 1 plus 4. 1 plus 4 is 5. Okay? For the numerator, this is going to be ugly. 2 times 1. 2 times negative 2i. Now, this is not a conjugate, so the o and the i's don't cancel each other, so don't think that. So for the outer terms, I get 2 times negative 2i is negative 4i. Inner terms, negative 3i times 1 is still negative 3i. And out last terms. Ooh, negative times negative is a positive 6i squared. Watch out for that, please. There's your negative 1 because of the I squared. And 6 times negative 1 is negative 6. Right there, okay? Clean up the top. 2 minus 6 is negative 4. And then negative 4i minus 3i is negative 7. Final answer, negative 4/5 minus 7/5 I. I know, crazy. Woo. All right, number 34. I promise this is the last one for this section. Check for the error. Looks like they foiled. Yep, that's right. 2 times 4. Outer term, yeah, 2i. Negative 3i times 4, yeah, that's right. And the last terms, let's see. Negative 3i times I, yeah, it's right there. So what did they forget? Oh, I see it. They forgot to take care of the I squared on the end, right there. That should be negative 1, yeah? So negative 3 times negative 1 is positive 3. Positive 3 with the 8 in the front will give you 11 minus 10i. That is the answer that you get. Okay? That's the positive 3. Yay! Any questions? Not too bad, huh? Woo. If you need to take a break, now's the time to do it. Go ahead and take a break if you have to. We are going to move on to 2-5. There are 3 more sections left. Crazy. Woo! Mr. Chan is definitely a little tired right now. We're going to try. Keep going. Okay? All right. Here we go. Skip through this guy right there. Circuits. Completing the square. As you recall from the lesson, when I actually did it, for 2-5, completing the square creates a perfect square trinomial, a PST, right? And the process is very straightforward. They use P's or something, I don't know why. Most everywhere else, when it comes to the standard form, they use ax squared plus bx. And usually you ignore the c there. You want to make sure a couple things. A is 1. If A is not 1, you got to factor that out. It's a lot more work. And if A is not 1, you got to factor out from A and the B part. Just remember that, okay? Then if A is 1, you can go ahead and take half of B and square it. That will complete the square. And when you do this, you do create a perfect square trinomial. All right, let's do it. Let's take 36 and complete the square. I'm going to save myself a little bit of writing, give myself a little white space. I notice right away A is 1, sweet. I'm going to take half of negative 16 and square it. Okay. I don't have to solve this. I just have to rewrite this. So that's all I care about. Half of negative 16 is negative 8. Negative 8 squared is positive 64. Oh my goodness. Now to balance this out, I got to add 64 to the other side. This is an equation now. Yeah? And eventually, I do need to move the 36 to the other side, so I might as well move that as well to this side. But I did create a PST on the part right there. That's a PST right there. Okay. All right. X squared minus 16x plus 64 can be factored very easily. That's x, 8 negative right there. 64 minus 36 on the other side is 28. Yes. And there's my answer. 28 equals to x minus 8 squared. And that's what they wanted. Kind of written backwards a little bit, but that's okay. That's how you complete the square. Remember, this is a balanced equation. What you do on one side, you got to do the other side. All right, let's try number 37. Same process. Ooh, here we go. A is not 1, is it? Oh boy. This is going to be a lot of work. All right. I got to take out a 4 from the first two terms because A is 4. So take that 4 out. Scooch the negative 42 off to the end, okay? When I factor out a 4, I'll get x squared minus 7x. Oh no, it's an odd number. I'm not liking this at all. I'm going to move the 42 to the other side right now to just get out of the way. Let's move it over there to the other side. Woo! All right, here we go. Our b value is negative 7. I got to take half of that and square it. Oh, I know. They could have given us something better, an even number. Half of negative 7 halves and squared is plus 49 fourths. Oh my goodness. I just pulled out of the air a 49 fourths. I need to balance it on the other side. But remember, we took out a 4 earlier. So I didn't add 49 fourths on one side. I actually added 4 of those 49 fourths. So I got to multiply that by 4. There's 4 of them, 4 copies. That's how the distributive property works here. But I did create a PST right here. Woo, this is an ugly fraction. All right, on the left side, I noticed something really cool though. I have right now a fraction that can be reduced. Psh, nice. So that's 42 plus 49 is 91. Does that sound right? Let me double check everything here. 4, 28, half of that is 49 fourths. Yeah, that sounds right. Move the 49 to the other side. Okay. So this is 91. That's amazing. And on this side, I have, yeah, 4 times that right there. That is going to be x, 7 halves, minus. Yay! 91 equals to 4 times x minus 7 halves squared. Now, interestingly enough, they went ahead and divided by 4 to the other side. Ugh. So the final answer is, crazy, 22.75 equals to x minus 7 halves squared. Okay? I know. Crazy. Oh, wow. All right. Number 38 through 41 is the same exact process, but you have to solve it. I'm not going to do all 4 of those. I'll give you the answer to all 4 first, and then decide which of the 4 I will be doing in a moment here. So right now, for number 38 through 41, let me give you those answers. We will skip 42 and 43, though. Let me give you the answers to number 38 through 41, and then we'll decide which ones we'll do by hand. Oh, my goodness. Here they are. Hold your horses. Number 38, x equals to 12, plus or minus, yes, we're going to get radicals here, square root of 226. Nice. Number 39, The answers are x equals to -7 plus or minus the square root of 43. Okay, more answers. Number 40, x equals to 2 plus or minus the square root of 41 over 2. Interesting. And number 41, x equals to, oh yeah, I'm not going to do this one, 7.5 plus or minus the square root of 44.75. Crazy. Let's try one of them at least. Any questions? We'll do number 38 off to the side here. All right, here we go. X squared minus 24x minus 82 equals to 0. Ooh, give myself a little space, complete the square. A is 1, that's good, yay. I'm not going to do number 39. Yeah, so that's too much. I might do 40, we'll see. A is 1 for number 38. Yay. Move the negative 82 to the other side. We're going to do that, all right? Let's complete the square. Half of negative 24 and squared it. So half of negative 24 is negative 12. Negative 12 squared is 144. Ooh, I got to bounce to the other side as well, right? Okay. We've created a PSC. X squared minus 24x plus 144 is factorable. That's x minus 12 times x minus 12. On the other side, we have 226. Oh, we mentioned that earlier. Yay. Put those together. And now we're going to go ahead and undo operations. Yeah, this is something we don't normally do. This is the most inefficient way of solving quadratics. We just have to show it to you. The whole point of completing the square is to show you how to put it into vertex form from Algebra 1, right? Square root both sides. That does produce a plus or minus. Square root cancel each other out. 226 cannot be broken down further. It's just 2 times 113. 113 is prime. Nothing comes out of that 226. Trust me. Add 12 to both sides. And there's your answer right there that I mentioned to you earlier. 12 plus or minus the square root of 226. Crazy. All right. I'm going to move on. I think that's plenty. If you'd like this, some help with 39, 40, 41, I'd be happy to do it. Just come see me. Whew. Take a break if you need to. This is probably the longest lesson of all time. All right. Let's move to the next section. 2-6. Yay! We're going to do something familiar. The quadratic formula. During the lesson, it was proven to you where that formula came from. You had to use completing the square with a generic ax squared plus bx plus c. And when you complete the square with that, you will get eventually this particular formula, negative b plus or minus square root of b squared minus 4ac all over 2a. And the saying goes, a bad boy couldn't decide whether to go to a radical party. He thought he'd be square about it. He missed out on 4 awesome chicks. And before he knew it, the party was over 2 a.m. That's what I remember from when I was a kid. All right. Part of this quadratic formula is to determine how many roots you have, real roots, just a system. And that's if you have something greater than 0, you'll have 2 real roots. The discriminant part, the b squared minus 4ac. If it equals 0, you'll get 1 real root. And if it is less than 0, meaning negative, you'll have no real roots, meaning 2 imaginary roots. Okay. Okay. All right, let's try some problems. Number 44. Here we go. Hey, x squared minus 16x plus 24. The quadratic formula solves everything for you. If you are in standard form, a is 1, b is negative 16, c is 24. Let's do it. I don't think I'll be doing all of them today. I'll just do a few of them just to practice. Here we go. X equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. We've done this enough, right? In Algebra 1 and even in Algebra 2 regular homework. I'm just going to plug the numbers in now. Negative b squared minus 4ac all over 2a. Clean that up. Two negatives become a positive. 16 squared is, holy cow, 225. Oh my gosh. Getting old here. Yeah. Aha, 256. Crazy, Mr. Chan. Minus, what is that? 96. Wow. Should have planned ahead, huh? Maybe break out a calculator. 256 minus 96 is 160. Ooh. Now you're not finished. You do need to break down the 160. And that's 2, 2, 2, 2. That's 2 and 5. Any pairs? Here's a pair. Here's a pair that comes out as 4, and we're stuck with the 10 underneath the radical. Yeah, we do. So this equals to 16 plus or minus the pair of 2's that come out. 2 times 2 is 4 on the outside, root 10 over 2. And that can be reduced further. You can take out a 2 in the numerator. I know, all this factoring, kind of a thing. And the 2's cancel each other right here. And there's your answer, 8 plus or minus 2 root 10. Yay. Let me give you the answer to number 45. They are x equals 2. Negative 5 plus or minus square root of 17 over 2. I haven't decided which ones to do, okay? Just let you know. Over here, number 46, x equals to 9 plus or minus the square root of 71 over 2. Same process as number 44, just to let you know. And number 47, the answer is x equals to 5 plus or minus the square root of 253 divided by 6. Crazy. I'll do one more. Which one fancies my curiosity? Let's do 46, okay? We'll skip 45 and 47. If you need me to do those for you in class, let me know. I'll do one more. There it is. It's basically the same thing, right? Identifying A, B, and C. Plug the numbers into that formula. Wow, this is the longest lecture ever. There you go. It looks like I'm going to have to multiply 18 times 18. Can't do that in my head right now. Kind of tired. What is 18 times 18? 64, 45, yeah, 324. Okay, works for me. 840. Don't mind me. 48. Oh, okay, that's break it downable. Let's break it down. Aha! 2 times 144. 144 is a perfect square. 12. Yes! Left over 2. Can that be reduced by 2? Yes, it can. Divide everything by, did I get it right? 12, 2, 144. Did I give you the wrong answer? I may have given you the wrong answer. Let me double check everything. 2x, 18, 5. 18, 18, 16, 16, 64, 6, 44, 18, 324, yeah. 324 minus 40 is 284. Oh. Good thing I'm double checking everything. That's 284, folks. Sorry about that. 42. 71. Ah, there it is. There's your 71. Ooh, good thing I caught myself. First mistake for this whole lesson, not bad. I'm going to reduce top and bottom by 2. Okay. Took out a 2 there, by the way. Took out a 2. All right. Reduce that. And there's your answer right there. I'm a little worried there. I am getting tired. Sorry about that, folks. Happens to the best of us. There it is. Wow. All right. Number 48 and number 49. Any questions about 46? All right. We're just finding out the discriminant, and that'll tell us how many solutions we'll have for number 48 and 49. Let's crank it out down here. 48. My function, my equation is there. So we're just seeing how many solutions we'll get if we ever graph this, yeah? A is 1, B is -24, C is 19. Put into the equation B squared minus 4AC. Plug it in, plug it in. Let's do it. B squared is -24 squared minus 4AC. So a lot of times you don't have to actually do the problem. 24 times 24 is kind of a big number. Minus a semi-big number. What is that? 36, 76? Yeah, this is going to be a positive answer. And because it's going to be a positive answer, I will get final answer 2 real solutions. That's all I care about. They don't want the actual solutions. They want to know how many you'll get, and that answer is 2 of them. Which moves me to number 49. Same process. Check out what the discriminant will give me. Holy cow. We're running to an hour and 26 minutes. That's crazy. A is 3, B is -8, C is 12. Boy, let's plug in B squared minus 4AC. Plug the numbers in. B is -8, A is 3, is 12. So 8 times 8 is 64. Minus 12 times 12. Oh, 144. Yay! That's going to be a negative answer. Which means I have no real solutions. We know this best as 2 imaginaries. Okay? All right, either one of us. Whew. You guys ready for the last section? The last section is going to go fast. Take a break if you have to. All right, 2-7, here we go. This is going to be a huge file. We're going to graph these all with technology. I am not going to do this by hand. This is all going to be Desmos or graphing calculator under graph. If you're going to use graphing calculator, be sure to use Shift GSolve ISCT for the intersection of those 2 equations. We have 4 we're going to do here: 53, 54, 55, and 56. We're actually going to get those on the graphing calculator. I'm going to give you the answers right now and show you under decimals. 53, if you graph it, you'll get this particular picture. Trust me. Yeah? 54, Oh, by the way, this is 2 solutions because they cross each other twice. That's it. They just wanted to know the number of solutions. Yay. And 54. Let me show you what that with decimals. So here we go. There's my first equation, turn on, and my second equation, y equals 3, there they are. Zoom in a little bit, they do intersect each other twice. Number 54 will look something like this. They don't intersect each other. Here we have 0 real solutions. I gotta be specific. These are real solutions, meaning on the number line. Here we have none. Let me show you that with decimals. Here we go. Turn off the previous 2 and turn on these 2 right. Oh, there it is. They do not cross each other at all. Okay. The last 2, we're going to actually solve. But before we can do number 55, unfortunately, it's not in slope-intercept form. That right there, when you move the negative 2x to the side, you'll get y equals 2x minus, plus 6. Okay, and that I can plug into decimals for number 55. In a moment, you'll get 2 answers. The intersection, they will be -3, 0, and 1, 8. Those are the coordinates. Let me show you. There's 55. Parabola and that. There they are. Wow. Here's the first one, -3, 0, and the other one is 1, 8 right there. Okay. Oh, last one. Can you believe it? Running into an hour and a half now. Can't believe it. 56. Mr. Chan, this is crazy. Here are the answers that we'll get eventually with our technology. -1, 6 for the first intersection and 0, 7 for the second intersection. Here they are. Under decimals. Turn those off and turn that on. There they are. Zoom in a little bit. There's one of the answers, 0, 7, and the other one right there, -1, 6. Woo! Can you believe it? We are finished. Unbelievable. I'm just going to apologize. What else can I say? This was a huge topic, chapter. Anyway, thank you very much. Go take a vacation. Talk to you later. Bye-bye.